Hello statistics students, this is Jami Emigh, and this video is our discussion on section 3.3, measures of relative standing and box plots. First thing I want to talk about is the z-score. The z-score is the number of standard deviations that a given value, x, is above or below the mean. So z-score, it's the number of standard deviations that a value is above or below the mean. Okay, so let's say your mean is right here in the middle. And if we're talking about a data value that is right here, one standard deviation above the mean, it would have a z-score of 1. This data value right here, if it were 2 standard deviations above the mean, it has a z-score of 2. Anything past that above the mean goes into the unusual range, as you guys know. So let's say we're right here, halfway between 2 and 3. That data value would have a z-score of 2.5. Let's go the other direction and look at a couple. To be 3 standard deviations below the mean would be unusual, and that data value would have a z-score of -3. Let's say you have a data value that's right here. Its z-score would be -1.5. I'm hoping that's right between -1 and -2. Okay, so the z-score is the number of standard deviations the value is above or below the mean. And we're using that +2 and -2 standard deviations away from the mean as the cutoff for ordinary or usual values and unordinary, unusual values. If you're looking at this number line right now and thinking this does not look familiar to me, maybe go back a few slides, but also maybe picture a bell-shaped curve over top. That might help put it into perspective. Empirical rules, this right here gets you 68% of your data. Here to here gets you 95% of your data. And here to here gets us 99.7% of our data. Maybe that make it look more familiar to you. I'm just going to erase all that so it doesn't get too cluttered. Okay, to calculate a z-score, we can, from a sample, you'll take whatever data value you're inquiring about. If you're like, okay, I want to know the z-score of that data value right there. You take that data value, you subtract the mean from it, and then you divide it by the standard deviation. Hit enter, and it'll give you the z-score. If you get an outcome that's between +3 and -3, or even maybe a little further, then you're probably good. If you get a z-score that's up here like 7, -9, maybe just recheck your work. It's not impossible to have a z-score of +7 or -9, but it would be a quite extreme data value. So just check your arithmetic if you get a z-score that's further away than like 4 standard deviations, just in case. Okay, I'm going to erase that again. I keep cluttering this page up with my markings. Okay, so let's say you are not looking at sample statistics, but instead you're looking at your population parameters. Okay, no problem, same scenario. So let's say this is your data value, like let's say that's your pulse rate. And you're like, okay, I want to know what my pulse rate is as a z-score. Then you would subtract the mean, that's mu, population mean, mu. Okay, pronounce it mu, you guys. And then divide that by lowercase sigma. That is the population standard deviation. Hit enter, and the number that it outputs will be your z-score, or the number of standard deviations your blood pressure is away from the mean, the middle one, the average. Okay, let me erase again so we can read that accurately. Feel free to pause this as much as you guys need to. All right, non-significant values are those with z-scores between -2 and +2 inclusive. That means including -2 and +2. So this is just another way that we describe the ordinary values. Let me highlight that area for you right here. So that is the ordinary values, which we also sometimes call non-significant. Just think of it as normal. It's the usual. It's another wording for it. Usual. Usual, ordinary, non-significant. It's just you're within 2 standard deviations of the mean. Significantly high values or significantly low values would then be in this range here or this range here. So further than 2 standard deviations away from the mean. We call those values unusual or significantly high, significantly low, unordinary, you might hear it called. So be practice with all 3 of those terminology, those terms. Non-significant, ordinary, and usual are all within 2 standard deviations. Unusual, significant, and unordinary would be the same terms for these ranges here. All right, Z-scores are very helpful measuring tools because it doesn't matter if you're talking heights or blood pressure or age, anything. That the individual unit gets taken out of the equation, if you will, and we just standardize it to +2 and -2 for any unit that we are addressing. We standardize it to +2 and -2, and then we don't have to know as much about each of the individual units like blood pressure or height and those cutoff points. We just know that their Z-scores have a standard cutoff point of +2 and -2. Okay, let's try this example. An author measured his pulse rate while writing to be 48 beats per minute. Is that pulse rate unusual if the mean adult male pulse rate is 67.3 beats per minute with a standard deviation of 10.3? All right, so there are 2 ways to approach this. I'm going to show you the first way, in which you draw a number line with the X values on it. And I'm going to try to make this number line up with the number line below. Okay, I'm going to label this one X values. This one down here is Z, okay? All right, so we're working with the top one. We're working with the X values. So we would put the mean pulse rate for males, adult males, in the middle. I'm going to try to line it up with the 0. Try to put it right over the 0 there, okay? 67.3 beats per minute. And then what we could do is add standard deviations and subtract standard deviations. So if I were to, I'm going to try to go right above the 1. And now I'm going to try to go right above the 2 and right above the 3. I'm going to try to go directly above the -1. I hope you can see how I'm trying to line these up because I want you to see the relationship between them. All right, I'm going to use my calculator. I'm going to start at the mean. This is X bar. So I'm going to type in 67.3. Take your calculator out and do this with me. 67.3. I'm going to add a standard deviation to that, so 10.3. That gives me 77.6. So that would be right here, 77.6. So someone with that pulse rate would have a Z-score of +1. I'm going to go again, plus 10.3. I've got 87.9. 87.9. That is X bar plus 2 standard deviations right there. And anyone with that pulse rate would have a Z-score of 2. I'm going to go one more time. Anyone with a pulse rate of 98.2 would have a Z-score of 3, which would be an unusually high pulse rate. In fact, anything above our 87.9 would make it into the unusual range. Okay, let's go the other direction. So clear your calculator, go back to 67.3. This time I want you to hit minus 10.3. And that gets us to 57.0. So anyone with a pulse rate of 57.0 would have a Z-score of -1. Okay, let's do it again. Minus 10.3. Now we're at 46.7. Any adult male with a pulse rate of 46.7 would have a z-score of -2, and that's still considered ordinary. But any pulse rate lower than that, any pulse rate lower than 46.7 for an adult male would make it into the unusual range. So I'm going to subtract 10.3 one more time just for completion of this number line. And any adult male with a pulse rate of 36.4 would have a z-score of -3, and that would be unusually low. Okay, so we are being asked to address this male author who has a pulse rate of 48 beats per minute. So let me change my color here. 48 beats per minute would be approximately right. I'm going to go with right there, okay? That's 48 beats per minute. So maybe beats per minute. Okay? So, our question we are being asked is that pulse rate unusual? And the answer is no. It is not unusual because it is in this range. It is within 2 standard deviations from the mean. All right. Well, that first method, although it works, that would be quite a bit for a doctor to have to create that number line, or to memorize, or to look up in a book that 46.7 and 87.9 are the cutoff points between usual and unusual, which is why it is very valuable to address this question as a z-score instead, because you won't have to, the doctor won't have to remember that it's 46.7 and that it's 87.9 that create the usual range. They would only have to know that the z-score has to be between -2 and +2, regardless of the units that we're addressing. Okay, so I'm going to try and erase as much of the clutter as I feel I can without losing. Okay, let's go with that. Okay, second method is to calculate the z-score. So we're going to use this formula here. The x value that we are interested in is 48. So we will do 48 minus the mean, which is 67.3, divided by the standard deviation, which is 10.3. Okay, type that in your calculator carefully. Make sure you put your numerator in parentheses or hit enter after you type in the numerator to follow the order of operations before division. And if you type that in correctly, you should get -1.87. Okay, -1.87 is a number between +2 and -2, so we immediately know that that value is not unusual. And you can see it on the number line, maybe right about here, -1.87. And look how they line up, and they should line up. If they don't line up, we did our arithmetic wrong, or we graphed the top line wrong. Okay, so that author with a pulse rate of 48 beats per minute has a z-score of -1.87. So if you're that doctor and you get the report, z-score, pulse rate, -1.87, you can immediately go, all right, it's between +2 and -2, so this is ordinary or usual or not significant. All right. Since the z-score is between -2 and +2 inclusive, his pulse rate is not unusual. I'm going to erase some stuff. There we go. All right, we have a couple examples here. So I would like you to challenge yourself by pausing this video and trying to work through numbers 1 and 2. Okay, welcome back. I'm going to work through these with you now, so check your own work. For the first one, if you got a z-score of -0.45, you got it right. Good job. And that z-score would mean, is the data value unusual? And the answer is no. So if you put -0.45 and no, then you got it right. Nice job. If you did not get that, let's check our work. We should have z equals x, this one right here, that's x bar, the mean. Standard deviation, that's s. And the data value we're interested in is that. So 327.83, subtract out the mean, and then divide that all by the standard deviation. So if you got it wrong, try typing it in like that. Careful of order of operation. Subtraction needs to be done before division. And then you should get that negative 0.45. All right, number 2, check your work. If you got 2.29 standard deviations below the mean, then you got it right. Nice job. So FYI, that would be a z-score of negative 2.92. But we weren't asked what's the z-score. We were asked how many standard deviations away from the mean is that. So it's this many standard deviations, but it's below the mean. So that word below addresses the negative part. A-T-I-V-E. And is that unusual for Mario to win only $177? If you said yes, that is unusual for Mario to only win that much, then you got it right. So these are the 2 correct answers in blue. And if you got it wrong, let's check your work. We should have z equals Mario's mean, x bar is 232, his standard deviation is 50, and last week, so the data we're interested in, the data value is 177. So we go 177 minus the mean, minus x bar, divided by s. And if we type that in correctly, we should get negative 2.92, making our answer 2.92 standard deviations below the mean. All right, let's move on to a topic called Boxplots. Boxplots are a visual tool that help us look at data values relevant to other data values. When I say relevant, I want you to think percentages. And the reason a boxplot helps us so much look at the percentages is because each quartile contains 25% of the data. For example, 25% of whatever this data is representing lies right here. The next 25% is right here, so a little more bunched together. The next 25% is right there, and the top 25% is the most spread out. So we have 25%, 25%, 25%, and 25%. So this is 100% of our data, but it separates it into quarters for us, and we can see how spread out or how bunched up the data is within each of those quarters or quartiles. A normally distributed box plot will look something like this. So our units here would be, looks like inches. So we're talking heights from a simple random sample of women. So women, our heights are normally distributed. About 25% of us have heights between 59.1 and 61.5 inches. The next 25% of us are here. This is our median, by the way. I'll show you that more. This is the next 25% of us. And women, the tallest 25% of us have heights between 64.95 and 67.8 inches. And you can see that each of the quartiles is about the same length, horizontal length, if you will. So that would be a normally distributed set of data represented in a box plot. This box plot is representing data that is quite skewed. So our units this time are dollars. We're talking salary in thousands of dollars of NCAA football coaches. Okay, so it looks like the lowest 25% of NCAA football coaches, I don't know what year this is from, I apologize, make between $125,000 and $205,000 a year. Salary always means a year. The next highest paid coaches, the next 25%, make between $205,000 and $300,000. The next highest paid group of coaches, that 25% make between $300,000 and $638.44 a year. And then this is possibly the most valuable point of this. The top 25% of coaches, their data is not bunched up. It's very spread out. So there's a large variation in this top 25%. They're paid anywhere between $638.44 and $2,840,000. What does that compute to? $2,840,000. That's a lot of money to make in 1 year. So if you're good at coaching football, maybe you spend some extra time there and see if you can find yourself being this guy right here, or girl. Okay, those two box plots you solved there are normal. No, I shouldn't use that word. They are not modified box plots. They don't represent any outliers as dots. Okay, let's look at this example. Maybe it's easier to explain by showing this. Here you can see there are these two dots. Up here, no dots, no dots. That doesn't mean there are no outliers. It just means that this type of box plot doesn't represent the outliers as a dot. But a modified box plot will highlight the outliers as dots. So if there is an outlier, you'll see it as a dot. And there can be an outlier on the negative side. There can be 1 on the positive side, 2 on the negative side. There's no restriction. It's just look for the dots, and each of those represents an outlier. So here we're talking pulse rates. So we have, of this set of data, we had 2 outliers with very high pulse rates. Okay. All right, we are going to learn how to graph box plots right now. And to do so, we are going to use technology. I'm going to be using my TI-84, and the program is called Zoom Stat. Excel has this program, StatCrunch has this program. The graphing calculator that I downloaded on my iPhone the other day is free. It has this program as well. But I'll be using my TI-84 if you want to follow along with me. Okay, we're going to use this example to construct our first box plot. The weights in ounces of 27 tomatoes are listed here. We've got 27 weights of tomatoes there. And we are asked to construct a box plot. And we're going to start by entering the data into list 1. Okay, so turn on your graphing device, and I'm going to hit Stat and then Edit. That's always where I enter my data. So go ahead and pause this video now and enter all of those data values, please. Welcome back. The next thing I want you to do is follow these steps here. Okay, we're going to go key by key. Let's do this together. I want you to hit second and then stat plot. And on the TI, stat plot is actually right above the key that says second. It's written in light blue for mine. It's above the Y equals key. All right, when you hit that, you should see 1, 2, 3, 4, and 5 different options. 1, 2, and 3 are all plots. 4 says shut off all the plots. 5 says turn on all the plots. We just want to graph one box plot, so we just want to turn on plot number 1. So when you're on the number 1, hit enter, and you want to make it say on, and you want the type of graph highlighted to be the box plot. So when you're hovering over on, hit enter, so it'll be highlighted. Now go through the different types. The first one is a scatter plot. And go over again. Oh, there's a histogram right in the middle. The fourth one over is a modified box plot, but this one just asks us to construct a box plot. So I want you to go over again to the fourth little graph, and it looks like a little tiny box plot, and hit enter once you're there. All right, next thing it's requesting is the X list. I entered mine into list 1, so I have the L sub 1 there. Frequency is 1. Okay, now we're all set. We're gonna hit, you know, this is the way I used to do it. You don't have to do second, quit, stat, edit, enter your data, because we already did that. We did that at the very beginning. All you have to do now is jump to this, zoom, and then the number 9, okay? So let's do that together. All you have to do is go to the top center of your calculator where it says zoom. Now you can scroll down to the 9th program, or you can just hit the number 9. The program is called Zoom Stat, so just hit the 9. And you should see on your screen your box plot starting to appear there. So all you have to do is trace that box plot into this space provided right here. Okay, just trace it. Just take it right from your screen, trace it with your finger, and I want you to label the 5 different numbers on that though. And the way you find those numbers is by hitting trace, and then you arrow to the left and or to the right, and at the very bottom of your screen it'll show you the 5 number summary. I need to pause my video and try to get that for you. Let me see if I can do this here. Okay, sorry, I had to pause that for a second. I can now trace my box plot. It's like that's off-centered. This goes over a little bit longer than the first whisker there. Okay, now when I hit trace, mine first highlights the median, the 2.8. So that goes right there. Now just arrow over. Here we have Q3. So this is the median. Now I'm going to go to this one right here. It's going to get a little cluttered, so I'm going to arrow over. 3.0 is Q sub 3. That's quartile 3. Our max is 4.2. It's the max. And arrow back the other direction. Quartile 1 right here is 2.5. Remember, these are ounces of tomatoes that we're talking here. And then last one is our min, which is 1.7. So that's the 5 number summary right there. Min, Q1, median, Q3, and max. Below this, it says use the same data, construct a box plot, and identify the outliers. So let me switch colors. This change in directions right here, identify the outliers, means to construct a modified box plot. Okay, so we have to go back in to zoom plot because we turned on the regular box plot. We need to switch it to be the modified box plot. Before I do that though, I just want to have a side note that if you hit zoom 9 and you have a dimensions error, you might need to clear your memory. Maybe someone else was using your calculator before you and they changed the window. So you can always clear your memory by hitting second, and then the memory key is MEM. It's right above enter. And depending on your device, it'll walk you through how to clear that, and it'll go back to all the default settings, and then try to graph your box plot, and you should be fine. Okay, so what I'm going to do now is hit stat plot. So second, stat plot. I'm going to go back into plot 1. I'm going to leave it turned on. I'm just going to change the type to the 4th one there. It's a little tiny box plot, but notice it has 2 little dots to the right. That's saying, okay, this is going to be a modified box plot. So I hit enter. And now I'm going to hit zoom, which is top center of your screen, calculator keys, and then the number 9 again. All right, so I have my box plot. Turns out that our minimum is an outlier. So 1.7 is now a dot. I've got to hit trace because I want to see what that next number is. Trace. This now starts at the number 2. Whisker, start of the box. Should look just like the one above, except that I notice there's my quartile 1, there's my median, there's my quartile 3. This whisker is going to be shorter, stopping at 3.6, maybe a little longer. And then we have an outlier. It turns out that our 4.2, that tomato, was an outlier. So we had 2 outliers in this set of data. We had one tomato that weighed very little and one tomato that weighed a lot, which is why we have 1 dot on this side and 1 dot on this side here. And that is our modified box plot. So regular box plot up here, modified box plot down here. Same exact data. Notice that they look very similar. It's just that the modified one highlights the outliers for us as dots. Okay, oops, there are the directions on how to get through that. But that will conclude our discussion on chapter 3, and I will see you next time.